Now let's go over question number 346, moving average from data stream. The question says, given a stream of integers and a window size, calculate the moving average of all integers in the sliding window. What they mean by sliding window is this window size. And if you don't know what a moving average is, we will go over that soon. And a key thing is that we are going to be given a stream of integers. Next, implement the moving average class, which is going to take a parameter of size, which is going to be a number. This initializes the object with the size of the window size. Next, we are going to implement a method called next, which returns the moving average of the last size value of the stream. Now, let's first go over what it means when they talk about size. And again, when they refer to size, they mean the sliding window. Now, when you are calculating a moving average, let's say we have a bunch of values. At first, we're going to have the number 1. And how do you calculate the average of this for now? Well, we have only one element, right? So this is going to be our average. And these are our values so far. Well, that's going to be 1 because 1 over 1 is 1, right? And how do you calculate average? If you don't know, it's sum over number of elements. Now let's say that we have 2 here now. So our sum is going to be 3, and 3 divided by 2 is 1.5. Let's say we have 3 here, so that's going to be 6, right? Our sum is going to be 6, and we have 3 elements, so our average is going to be 2. And let's do one more. Let's say we have 4, and that means that we have 10 as our sum, and our average is going to be 10 over 4, which is going to be 2.5. Now that's just regular average, right? But if we were to calculate a moving average, and let's say our window size is equal to 2, that means when we calculate our moving average, we want the 2 of the most recent numbers to calculate the moving average. So let's try how that works. Our first number is 1. So 1 over 1 is same thing, 1. Now it's going to be 1 plus 2, which is 3, right? 3 over 2 is 1.5. So far, everything's the same. But now, remember that our size of moving average is 2. So that means you want to calculate 2 plus 3 only. So we want the 2 most recent numbers to calculate the moving average. Hence, the definition or the name moving, because we're moving across the values. So that's going to be 5 divided by 2, which is 2.5. And now it's going to be 3 plus 4, and 3 plus 4 is 7, and 7 divided by 2 is 3.5. And you can see how our averages compare, right? This is just regular average, getting the total sum divided by total number of elements. But for moving average, we're looking at the 2 most recent pairs of numbers. So 1 and 2, 3 and 2, and 3 and 4 to get a size of 2 to find our moving average. So in a sense, our average is actually moving depending on the window size. So let's just go over our example one more time, which is going to be pretty much the same. Now we're given the moving average, and this number is going to be our size. So when we calculate our average, we're going to have 3 elements. Now our first number is 1, and that means that so far, since this is the first number, we are going to have only one number, and 1 divided 1 is 1, which we get over here. Next is 10. So 10 plus 1 is 11. So 11 divided by 2 is 5.5. And next is going to be 3. Well, that's going to be 14 divided by 3, and we get 4.6667. And finally, we have to recalculate our moving average because we want the 3 most recent ones since our size is 3. So we want to take out 1 and just keep 10, 3, and 5. So that's going to be 18 divided by 3, which will get us 6. So you can see that our size is at first 1 because we only have one element so far. Then it's 2, then it's 3. When it hits 3, it's going to be never smaller than 3 because our average is keep going to move along the values, and only our values are going to change. You can see that we took out this number 1 when we calculated our moving average. So we have 10, 3, and 5, but not 1. And we have a total of 3 elements. If you guys find this helpful, make sure you guys like and subscribe. Thanks. Now let's implement our solution, and our first solution is going to have a time and space complexity of O of n, and we'll slowly optimize this as we go through this whole video. Now, first thing we have to do is we have to create our moving average constructor function, and this is going to have two properties. First one is going to be size, and size, remember, is our window size. So at maximum, we can have size number of elements to add. Next, I want to create something called this.values. And this is going to be an array that stores the values that we get. So it's going to store 1, 10, 3, and 5. And these are the values that's going to be passed in. So these are the stream of integers that we get. And here we have our size. So that's actually it for our moving average constructor function. So now let's implement our method. Now, if you remember, our size is going to be 1 for this one, 2 for this one, 3 for this one, and then for the last one and going on, it's going to be 3 because our maximum size is defined here, which is 3. So let's try to first calculate our size. So I'm going to declare a variable named size and set this equal to. Now let's think. Well, as long as the length of my values array is less than the given size, I want to return the length of the array. If not, I'll just want to return the given size. What we need to do is we need a condition. So if this.values.length is less than the size given, well, if that's true, I just want to return this length. So let's return that. And I actually have to add 1 here, and I'll show you guys why soon. Otherwise, I want to return the given size. So let's console log size and see if that works. And it's actually not gonna work. We have only ones here. And the reason is because we haven't added any elements to our array. So let's add that here. So that's going to be this.values.push, and we push in our value. And you can see that we have 1, 2, 3, 3. That's our size, right? It's going to be 1 for the first one, 2 for the second one, 3 for the third one, and going forward, it's always going to be 3. Now, going back to size, why do we have to add 1 here? Well, the reason is because at first, our values array is going to be empty, right? And we can't have a size of 0. So that's why we added 1 here. But you can actually get rid of this by switching some lines. So get rid of that. And you can see that it's going from 0 to 3. And we don't want that. So what we can do is get rid of that +1 and put this above where we calculate our size. And you can see that our size is looking good. But I want to actually just keep it down here. It's just the preference. So if you wanted to put it up here and then just get rid of the addition size, that's totally up to you, but I'll just leave it at this. Now, our size is looking good, and we just have to be able to calculate our sum. Now, we know that our values array is always going to keep all the stream of integers in this array. So let's just console log our values array to see what we get. And you can see that we have our stream of numbers. So 1, 10, 3, and 5. Now what we want is we want the most recent size number of elements. So at first, we want to keep everything. Second, we keep everything. Third, we keep everything. Well, last, we don't want to keep everything. We want everything except 1. So we want the most recent 3, which is going to be 5, 3, and 10. So what we can do is we can iterate backwards and get most recent size number of elements. So let's try to implement that. So I'm going to call this sum, and as we iterate backwards and get our number, I want to add it to this variable. And I want to use something called reduce write. Just think of reduce write as for loop backwards. So let's run this stuff values, and let's run our reduce write. And this is going to take two things, our accumulator and our value. And we're going to start with the sum of 0. And I want to actually create another variable before I calculate my sum. And that's going to be called count. And what count is simply going to do is just count the number of elements that we added to our accumulator so far. So we're going to compare count with the given size. And as long as the count is less than the size, we want to add our current value to our accumulator, which eventually is going to be our sum. So if my count is less than the size, what I want to do, I want to add current value to my accumulator. And later when I'm done, I just want to return my accumulator. Now I have my size and my sum, And how do we calculate average? Average is total sum divided by the number of elements, which is represented by size. And let's see if that worked. So that actually didn't work, right? We have 5.5, which looks good. We have 4.67, but right now we have 6.3. And the reason is because we couldn't get rid of the last value, which is supposed to be the number 1, and it's putting that into account. So this right now is doing all the numbers added divided by 3. So let's console log our sum. So we have 1, 11, 14, and 19. And if you were to add everything on, it's 1, 11, 14, and 19. But since our size is 3, we have to only add the last 3 and get our sum, right? So we want to stop when our count becomes the same as our given size. And if you look at our code, there's something wrong, right? And think about what's wrong. Well, our count is what? It's 0, right? Well, does the count ever change here? No, because we aren't changed the value of count anywhere at all. So what we have to do is each time we run this, we just have to increment count by 1. And if you do that, you can see that we get our result, which is 1, 5.5, 4.67, and 6. So that's it for our solution. And I do have some more examples. Let's try to comment those out and see if it works. So for the second one, you can see that as 50, which is correct. Next is 25 and 75. And let's uncomment these two. And you can see it's 100, 45, -70, -40, and -65. So that's it for our solution. Now I do want to go over our solution really quick, just one more time, and talk about what we did. So here we're just creating our constructor function, which has a size, and size is going to be again passed in, and this is our window. Next is where we store our values, and from here we are going to get our sum. And next is our next method. Now we are going to be given stream of integers again, and if you look down, we have our stream of integers, first one being 1 and the last one being 5. First thing we do is we create our size, and you saw that our size is correct. Let's console log one more time. So size, it's 1, 2, and 3, and 3. And okay, I commented the other ones out. So here we get our size, and you can see that it's 1, 2, and 3, and 3. So it never goes up above our window size. And here we add our value to our values array. And here we iterate through our values array and get the sum that we want, and we store it into this variable. And to do that, we are using something called reduce write. So reduce write, just think of it as for loop looping backwards. So our values array is going to look like this, and it's iterating starting from 5, and it's checking, well, is the count less than the size? Well, if it's true, I want to add 5 to my accumulator, which is 0 for now. And then the next number is going to be 3. Well, does it satisfy this condition? Well, true, right? So it's going to add 3. And next is going to add 10. And finally, well, is count less than the size? Well, it's not, right? Because count is going to be 3. And 3 is not less than the size. So this whole thing skips, and this runs one more time, and finally we just return our accumulator and then just save that to our sum variable. And that's how we get our sum here. So it's 1, 11, 14, and 18. But if we didn't have our count, you saw that it just kept adding everything. So the last sum didn't take out the first number, which was supposed to be out from our sum variable. So let's keep that, and you can see that our last sum was correct with the value of 13. And finally, we get our moving average. Again, average is sum divided by size, and we get our result. Now let's go over our second solution, where we optimize our time complexity a little bit, and as a result, our time complexity is going to go down from O of n to O of size. Now if you remember from before, we iterate through our array O of n number of times using reduce write. So we are iterating through the whole thing, but here we want to only iterate whatever our size is. And for this solution, we're going to use ES6. So we're using just regular classes instead of a constructor function. So it's much shorter, a lot less coding. So let's start implementing our solution. So first one is I want a property named size, and this is going to be have a size. I want a values array like before, where we will store our values. And next, I want to create a property called first. And what this will do is it will just be an index. And I'll explain about this more later. But what this will do in general is it just points to the first instance in my values array where I should start adding elements from. Well, if you have 100 elements and our size was just 2, we don't need to iterate through the whole thing and then add up the last 2 numbers. We can just point where to start adding up our numbers, and we're going to use first pointer for that. Now let's implement our next method. So like before, we need to get our size, and if everything is too fast, I definitely recommend you to go over the first solution because we go everything in detail. So if my length of the array, values array, is less than my size, what I want to do is I want to get my values array's length, add 1. If not, I want to just return the size. So let's console log if that worked well. It shouldn't because we haven't added up any elements. So let's add elements to our values array. And you can see that we have our correct size. So 1, 2, 3, 3 because our window or our size window is 3. Now it is going to be the difference between our first solution and our second solution. If you remember, our first solution used something called a count variable to check how many times we added numbers starting from the back of the array, right? But for this one, we're going to use a first variable, and if you want, you can actually use the same count variable logic here, but I wanted to do something different because it's good to solve problems in a different way. It makes you think, and I think that's really valuable. Now, before I illustrate how first works, I want to console log 2 things. First one is the values array, and second one is the first property. Okay, so for now, first is going to be always 0 because we haven't done anything with it. Well, let's look at our values array. Well, our values are being added to our array, right? Well, if you were to get the correct moving sum, what we need to do is we need to just add size number of elements, the most recent size number of elements. Well, for the first one, we add 1 because we only have 1 element. For the second one, we add all of these because we only have 2. 3, same logic, we add all of them up. But for the last one, we want to add starting at 10, 3, and 5 because we want the most recent 3 numbers. So we don't want to add 1. So what first pointer will do is it's going to point to an index where we should start adding our numbers. So for our last one, it should point to 10 because starting at 10, I want to add numbers to my sum. So that's going to be 10, 3, and 5. Now, if you were to have more elements, it would obviously point to 3. So we would add 3, 5, and whatever that new element is. The point is that our first pointer is going to point to number 3, which is index of 2. Now, how do I make my first pointer point to the right index? Well, what I can do is I need to check. Well, if the length of my values array is greater than my size, what I can do is I can increment my first pointer by 1. Now, if I were to do that, you can see that my first pointer is 0, 0, and 0, and finally it's pointing to the right index where 10 is standing, so index 1 over here. Now again, if you were to add more elements, obviously our first pointer would increase so that it would point to 3, 5, so on and so forth. Okay, so given that, let's try to calculate our sum. Now in order to calculate sum, I want to use a for loop, and the important thing is where is my index going to start? My index is going to start where my first variable is, and I want to iterate until the end of the array, so that's going to be this.values.length, and we increment by 1 each time. Now let's create our sum variable. So let's do let sum is equal to 0, and here we'll add our values to sum. Sum plus equals this dot values at index I, and we added our sum. Now let's console log our sum and see if we get the correct sum. And you can see that we get 1, 11, 14, and 18. And if we were to add 1 to the last one, we would get 19, which is wrong. So we know that our for loop is working well. We're getting the right sum. Now let's finally return our moving average. Our moving average is going to be sum divided by size. And let's go down and check if we get the correct answer. You can see that we're getting the correct answer 1, 5.5, 4.67, and 6. So that's actually it for our solution. We know that it's working well, but let's just go over one more time really quick. Now we have our constructor function with a difference of size, and size is set to 0. And remember that first is just a index that points to where we should start looping, which we use over here. So we were able to optimize our code to O of size because we are starting at this stuff first instead of index of 0. Now we got our size, and this is going to return us the correct size that we have to use. So it's going to be never bigger than the size input. We add our value to our values array, and then we check, well, is the length of the values array greater than the size? If it is, I want to increment my first pointer by 1 because I need to keep moving my pointer as we add more elements, and we add up our sum here, again starting at the first pointer, and finally we return our moving average. Now we want to implement our last solution where we optimize our time complexity to O of 1. So obviously it's better than O of n and O of size. If you remember from our second solution, what we did was we had the first pointer that points to index where we should start adding up our values. For this one, we're going to do something similar, but this time we're going to keep a running sum, and each time the length of our values array goes up by 1, we're going to subtract a number each time instead of incrementing our first pointer. So let's try to code that. Same as before, we want a size. We're going to have our values array. That's going to be an array. And we're going to have our sum here. Next, we want our size. So that's going to be the same. We did this 3 times. If values array length is less than input size. If this is true, we want to return the length of the values array plus 1. Else, we want to return the size. Okay, let's console log our size just to check. And we have to actually add our values, and you can see that our size is looking good, so it's working well. Now what we need to do is we need to add our value to our sum. So this dot sum plus equals our value. Now if you were to console log our sum, it should be this dot sum. You can see that we have our running sum, but remember that we have to subtract 1 from the last one because we want the sum of the first or last 3 values. So how do we handle that? Well, like before, we're going to have a condition. So if this dot values dot length is greater than this dot size. So we had this same condition as before, right? And what we did before was we just incremented first pointer by 1. But for this one, when this condition evaluates is true, we're going to subtract the number from our sum. So let's just actually console log our values here. And we're going to keep a running sum, and we're going to save our sum over here. At first, it's going to be 1, 11, 14, and then 19. So when it's 19, that happens when our value's length is greater than our size. So length is 4 and our size is 3. So what do you want to do? Well, we want to subtract this number. And as we add more elements, so let's say that we have one more element here. We want to subtract 10 from that number because we subtracted 1 previously. It doesn't matter. So we're going to keep subtracting each number as we add more elements to our values array. So let's implement that. So that's going to be this dot sum minus equals this dot values at a certain index. Well, how do we get the index? The index is actually represented by this dot values dot length minus 1. So this right now is just getting the last index, right? Last index, which is right now 0, 1, 2, 3. And if you want to subtract this 1, how can we do that? Well, we know that this right now, the values length minus 1 represents index 3. Now we need to subtract index 0. So how can you make this 0? Well, what we can do is we can just subtract the size. And if you were to do that, we're subtracting 1 from sum of the whole thing because we added everything up here, and we're setting new value, new sum to our sum over here. So let's just console log our sum here. It should be this dot sum, and actually let's console log it up here too. So you can see that we have 1, 11, and 14, and when the value's length is greater than 1, what we did was we got rid of the element at index 0 because that's the element we want to subtract from our sum. And you can see that we have 18. So as we add more elements, after we're going to subtract 10, 3, 5, and so on and so forth. This whole operation is just all one, right? We are not having any loops. So this is actually a lot faster. Now finally, what we have to do is we just have to return our moving average which is going to be this dot sum divided by size. And if you were to check our result, you can see that we have a correct working moving average. Now let's go over our code one more time. Well, you see that this is the same for all three solutions. We're pushing in our values, and then we're adding our sum to over here, and then we check, well, is the value's length greater than my size? If that's true, I need to subtract an element from my sum, and this time it's going to be my index 0. So I'm going to get my index and subtract that value from my sum, and then return my moving average. And as we get more elements, my index is obviously going to change. So let's say that we have 5 elements, so one more. So that means that this line over here, so values.length minus 1 is going to evaluate to 4. And if you were to subtract size, which is 3, that's going to be index 1. So index 1 is our number 10. So we're going to subtract number 10 from our sum, and we get the new sum and just get the moving average. Now let's try to implement our last solution, and our last solution is going to be the most optimized solution. So we're going to have a time complexity of O of 1 and space of O of size. Now, if you remember from our previous example, we had a space complexity of O of n, and that was because it depended on the number of inputs. Now, for this solution, we're going to have only size number of elements in our values array. So think about how you can implement that. Now let's try to code our solution. First thing I want is I want my size property, set this equal to size. And next is my values array, and that's going to be equal to an empty array. Now we need our sum, set this equal to 0. And next we need our index. And next, finally, I want my length. And this is also going to be 0. Okay, let's try to implement our solution. First thing I want to do is I want to add my current value or value that's given to my sum. And next I want to check, well, if my length is equal to size, that means that I'm going to have an overflow if I were to add more elements. So if this dot length is equal to this dot size, well, if you remember, what we did before was we subtracted elements, right? So here we're going to do the exact same thing. So if we have more than 3 elements, we subtracted first one from the sum. So here we're doing the same thing. So this dot sum is minus equal this dot values at our given index. Otherwise, we're going to increment our length by 1. Okay, that looks good. And if this part confuses you, we'll come back to it. I think if we were to code everything out, you would have a better understanding. Next thing I want to do is now I want to be able to add my value to my values array. So let's do that. So this dot values, and I want to insert it at our index. So that's going to be our index, and we set it equal to our given value. Now we have to increment our index each time we add our value. So let's do our post increment. And next we need to have our index. Well, remember that our values array, it's going to have a complexity of O of size. So it means that at maximum, we're going to have 3 elements. But as we have more and more elements, the first one is going to be replaced, second one, third one, first one, second one, third one, and like so on and so forth as we run this many times. So how can we implement that? So that means that we have to somehow change our index. So index is going to be ranged from, if you were to have size of 3, it's going to be 0 to 2. That's going to be our index. It's going to keep repeating 0, 1, and 2. So what we can do is we can actually use something called the mod operator. So what we do is we set our index equal to this dot index mod, and we mod it by the size. Now, if I were to just console log that, you can see that our index keeps iterating from 0 to 2. And this is 1 because we incremented our index over here. So if you were to just console log up here, you can see it's 0, 1, 2, and it's repeating 0, 1, 2 infinitely. Now, finally, we're actually done. We just have to return our moving average, which is this dot sum divided by this dot length. Let's check our result. And as you can see, we have our solution. It's working well. So now let's just go over this code. So our length is keeping check of length of values array. the sum, we have the size, we have our values array, which at maximum it's going to have only 3 elements. So actually let's just console log that over here too, just to see how it works. So console log this values, and you can see that we have our array. So we start with 1, we add 10, we add 3, and now what happened is the length of the array is same as our size. So what do? Well, we first have to subtract the element at this dot values at our index. And what's our index? Let's print it out one more time. So console log this dot index. You can see that our index is going to be 0. So what's the element at index 0? It's 1. So we subtract 1 from our sum. And if you remember, that was 18, right? We get a sum of 18. Before it was 19. So that's exactly what this line is doing. And if you were to have more elements, what it's going to do is it's going to subtract 10 and probably add the other value. Otherwise, we're incrementing our length by 1. And in the next line, what we're doing here is we're just simply storing our given value to our values array. And again, remember that our index is going to be 0, 1, 2, repeating over and over again. And over here, we are doing just that operation. We're doing index mod size so that we can get repeating index over and over again. And finally, we just return our moving average. So that's it for our solution. And that's it for our question. If you guys find this helpful, make sure you guys like and subscribe. Thanks.